Right, welcome back. All right, so using limits, we're going to apply the three-step method to compute the derivative of the function. We're going to write it as a difference quotient, and we're going to simplify and take the limit as h approaches 0. Now we can do that. We can do all three steps in one if we write our steps correctly. All right, so it's going to be the limit as h approaches 0. Right, and just a reminder. So, all right, we just take that and we make it the limit as h approaches 0. All right, so that means, oh, I don't like the a of 8. So we're using x. I like x instead of a. All right, so the limit as h approaches 0, f of x plus h minus f of x, all divided by h. But it doesn't matter what variable you use. Right? X is more common, so we'll just call it x. All right, so now everywhere we see an x, we're going to plug in an x plus h. Right? So we have negative x plus h squared plus 0.5 x plus h minus 2, and then we're going to subtract f of x. So we're going to use parentheses, so remember to distribute the negative. So we have negative x squared plus 0.5x minus 2, and that's all over h. If you can remember, the rule for squaring makes that easier. The limit as h approaches 0, the negative gets distributed last. So this would be x plus h squared, which would be x squared plus 2xh plus h squared. All right? That's what it would be squared. And then we have, we'll distribute that 0.5, and we have plus 0.5x plus 0.5h minus 2, and then we'll distribute the negative. So then we have plus x squared minus 0.5x plus 2. All right, and so now we need to distribute that negative, all over h. All right, pretty quickly this is going to simplify. So the limit as h approaches 0, we've got a negative x squared, a negative 2xh, a negative h squared, a plus 0.5x, a plus 0.5h, minus 2, plus x squared, minus 0.5x, plus 2, all over h. Look at all those terms. I really should have written a little smaller, huh? Or just move the problem up a bit. I think that's all connected. I don't think I can move that up at all. All right, so actually I'm going to, I can. So I'm going to take advantage of that and move this up. There we go. Before I run out of space. And then I'm going to try to grab everybody, but I don't see grabbing. No, I just see my problem moving all the way into the corner there. Let's see if I can get everybody to, and that I wrote here. There we go. Let's see if we can grab everybody and move everybody up just a smidge. All right, everybody move up. There we go. I have a little bit more space now. All right, so now let's see who cancels out. All right, so there's a negative x squared and a positive x squared. Those are gone. A 0.5x and negative 0.5x, negative 2, positive 2. All right? And if you don't mind, since I'm running out of space, let's combine two steps at the same time. Limit as h goes to 0. We know we're going to factor out an h. Everybody's got an h, right? So let's just factor out the h to begin with. So we can do a little reducing. All right, so then we'd have a negative 2x minus h plus 0.5. If I've lost you by factoring out the h when I wrote it, just let me know and I'll go over it with you again, okay? But I'm going to run out of space. So I thought, well, rather than writing it, we'll factor out an h at the same time. Of course, the h's cancel there, and now I'm no longer indeterminate. Yay! So now we can plug in the 0 because we're done taking the limit. Notice we had limit up there until now because now we're substituting in. So we have a negative 2x And we have minus 0 and minus 0.5. Right? So that means our derivative, f prime of x, oh, you know, I forgot to write it all the way through. Because this is what we're finding, right? And since I have a little bit of space, I'll squeeze it in. Just so that we remember what we're finding. So f prime of x is equal to negative 2x minus 0.5. There we are. That equation represents our derivative. And if we want to know the slope of the tangent line, which is the instantaneous rate of change, we'll just plug into that equation there. But for now, we're done with this problem. Right? So it looks like a lot of work, but look how quickly everything started canceling out. That wasn't so bad, now was it? No. All right, let's try another one. All right, so before I even start, I want to move everybody up. All right, same thing. All right, so we're going to plug in and take the limit. As h approaches 0, everywhere we see an x, we're going to plug in an x plus h. All right, so we have 1 divided by 2 times x plus h plus 5, and then minus 1 divided by 2x plus 5, all divided by h. And this is a good problem for us to practice because sometimes you guys have difficulty with the fractions. Right, so we need our least common denominator. And that's just going to, but since they're both different, it's just going to be the product. So 2 times x plus h plus 5 times 2x plus 5. And there's no reason to multiply those. It's fine just like that. Don't give yourself extra work. It's unnecessary. So let me write in f prime of x since that's what we're solving. And I already forgot to write it once. All right, is equal to the limit as h goes to 0. So numerator and denominator are going to get multiplied by what they're missing. Right, so this one is missing the, I'll have to write it small, the 2x plus 5. Right, so that needs to be multiplied by that in the numerator and denominator. And the other one is missing the 2 times x plus h plus 5. Right, so we'll have to multiply the numerator and the denominator by 2 times x plus h plus 5. There we go. All right, so no reason to write our denominator twice. Right? We know what our denominator is going to be. 2x plus h plus 2x plus 5, the product of those two. So let's just write it in, okay? And then we'll have one denominator for both of them. All right, so we have 1 times 2x plus 5, which is 2x plus 5. Oh, and let me just throw in my divided by each there. And then we have 1 times, but is it 1? No, my number here is blocking it just a little bit. But there's a negative there. Let's put it like this so you can see the negative. All right, so don't forget you're distributing. So it's going to be minus, right? So it's going to be minus a 2 times x plus h plus 5. Right? So everyone's going to be the opposite. So now we have one fraction. Now we can start simplifying. All right, so we're not going to do anything with the denominator. So we have a function in the numerator, right? That's a fraction. It's got a numerator and denominator. And in the denominator, we have our limit here. We just have the h. So we have f prime of x equals the limit. All right, so we'll distribute the negative. Actually, I think I'm going to write on the next line. I'm going to run out of space if I do that. So f prime of x equals the limit as h approaches 0, and we'll distribute the negative and distribute at the same time, right? So we have 2x plus 5. This is going to be, so if it helps, we can make this a plus and make that the negative, right? So we're multiplying, actually, no, I can't do that because the 5's not getting multiplied by the 2, but we are distributing the negative, so never mind. Can't make it easier for you. Sorry about that. So this was a 2 there. So just remember, everybody gets the negative. Okay. So we have 2x plus 5, so that's going to be minus 2x and minus 2h and minus 5. Right? So everybody gets the negative. But the 5 doesn't get the 2. And then divided by 2 times x plus h plus 5 times 2x plus 5, which we are not going to distribute or multiply in any way, times h. All right, so now we'll simplify. So look, this isn't so bad, right? Because the x's will 2x's will cancel. And the 5's cancel. Right? Those are opposites. All we got left is the, where is he? The negative 2h. That's it. So now we've got f prime of x equals just a negative 2h divided by a 2 times x plus h plus 5 times, it's a mouthful of a denominator there, 2x plus 5. And whoops, what happened to my plus? There we go. Rather than divided by h, why don't we just put times the reciprocal? That'll make it easier for us to simplify. So let's just put times 1 over h. And then we can see we need to cancel out the h's. Right? Sometimes you lose that when you see divided by. So now we have, we're almost done, f prime of x equals the limit as h approaches 0. We have just a negative 2 in the numerator, and then we have that mess in the denominator. 2 times x plus h plus 5 times 2x plus 5. But now all we have to do is plug a 0 in for the h's. So we're almost done. So our derivative is just going to be, so in the numerator we have a negative 2. In the denominator, right, we're going to plug in a 0 here. So if we plug in the 0, because I'm running out of space, that's just going to be 2x plus 5, right? So 2x plus 5 times 2x plus 5. You can leave it like that, or you can write it as negative 2 divided by 2x plus 5 squared, whichever you prefer. What I wouldn't bother to do, there's really no reason for me to multiply 2x plus 5 times 2x plus 5. Looks perfect like that. And there we go. We found the derivative. So this is probably a good one for us to practice, and that is when we have our function is a rational function. How do we do that? All right? So good practice for us, or for you anyway. All right, so here we have a real world problem. The demand for an item is d of p equals negative 2p squared minus 4p plus 300. It's a function there, where p represents the price of an item in dollars. We want to find the rate of change, right? That is derivative, right? If it said average rate of change, right, that would be the slope of the secant line, right? But it is the rate of change, so it is the derivative, instantaneous rate of change. Right? And notice we're looking at a specific point. We're not looking between two values. So this is our derivative, which is also the instantaneous rate of change. All right, so we're going to take the derivative. Right? So we want d prime of p, which is the limit as h goes to 0 of negative 2 p plus h, then we got p's, p plus h squared minus 4 p plus h plus 300 minus negative 2p squared minus 4p plus 300 all over h. Long equation there, but it'll simplify pretty quickly. D prime of p equals the limit as h approaches 0. So I'm going to square and then we'll multiply by negative 2. This is going to be p squared plus 2ph plus h squared minus 4p minus 4h plus 300 plus 2p squared plus 4p minus 300 all over h. The last thing we need to do is distribute that -2, and then we can start canceling terms. Right? So negative d of p equals the limit as h approaches 0. That would be a negative 2p squared minus 4ph. Oops, I said h. Why did my hand write a p? All right, so minus 4ph, and then minus 2h squared, and minus 4p minus 4h, plus 300, plus 2p squared, plus 4p minus 300. Whew, that's a lot of terms. All over h. But thankfully, some of them are going, which is good. I'm running out of space. So 2p squareds are gone. And the 4p's are gone, right? Because it's negative and positive. Anybody else? 300 and negative 300 is gone. All right, so we're just left with 3 terms. So we have d prime of p is equal to the limit as h approaches 0. If you don't mind, we've got the 3 terms here, right? 1, 2, 3. Notice they all have an h. If you don't mind, let's factor out the h right away. So h times, and then we would have a 4p minus a 2h minus 4, all divided by h. And so now the h's would cancel, so it's no longer indeterminate. And so now, go away. Go away, h's. I crossed you off. I thought I did. All right, go away, h's. Are they going away? Well, I'm just going to write without you. Eventually, I think you'll go away. All right, so I don't know why my h's aren't going away. Let's try one more time. Ah, finally. That shouldn't be so difficult. All right, so now we can just plug in. So we have d prime of p is equal to, so we plug in 0 for h, right? This is going to be 0 right here. We're going to have minus 2 times 0. That's just 0, right? So that's going to be 4p minus 4. So this is our derivative right there. All right? And again, I wrote too big. All right? So, but we were asked to find and interpret the rate of demand when the price is $10. I'm going to have to extend the page a little bit, so I have a little bit more space. So now we're going to do the part B. So that was the part A. But actually the part B is pretty quick. All right, so we need to find d prime of 10, which is going to be 4 times 10 minus 4, which is 40 minus 4. Right, so that's just going to be 36. And what does that mean? So we're going to interpret it. All right, so remember that's the slope of our secant line. Right, it's our instantaneous rate of change. Right, so, and it's referring to the demand, right? The change of demand. Right? And our P, let me make sure I understand. Let's read the problem one more time real quickly. So that P is at the price of the item in dollars. Find the rate of change of demand with respect to price. All right. So our price is $10. So when the price, where are my words, equals $10, the demand, not the demand, but the rate of demand. So what's increasing is not our demand, but the rate of demand. So the rate of demand increases by 36. Right? So that's our slope of our secant line. So we have an increase of 36 when our price is $10. Right? So that's actually a good thing, right? Because it's positive. So our rate of demand is increasing if we're at $10. So that would be a good choice. If we change it to something else, we might find we change it too much and our rate of demand decreases, and then that would be bad. Right? So if we want to find any type of rate of change, we take the derivative, and then if we're given a specific value for our deep and independent variable, right, we can plug that in and then interpret it, just like we did here. We have a couple more problems. All right, so I think actually we have maybe three. The profit in thousands of dollars from the expenditure of X $1,000 on advertising is given by P of X equals 1,000 plus 32X minus 2X squared. Find the marginal profit at the following expenditures: 6,000, 8,000, 12,000. You know what? I think, since I'm at 21 minutes, I'll save this problem and then this problem. And then we'll look at velocity, and we'll revisit Wile E. Coyote in the next Nearpod. All right, so we'll save these last contextual problems for the next Nearpod. Thanks for watching this one. All right, bye for now.